All right, integers and absolute value. Well, before we talk about integers, we need to talk about whole numbers. And whole numbers are, look at the word whole in there. It's like a donut hole. So 0 is the first whole number there is. And the next one's going to be 1, 2, 3, all the way up to as high as you can think. So basically there's just no decimals. So whole numbers do not have decimals. And they don't have negatives. So no decimals or negatives. All right, so that's what whole numbers are. Now, integers are just like whole numbers, except they include all of their opposites. So they include all the whole numbers, but they also include numbers like -3, -2, -1. I'm going to put a dot, dot, dot to show it keeps going further to the left. And then 1, 2, 3. And then a dot, dot, dot to show it keeps going to the right. Now we use negatives and positives to express different numbers, and I'm going to give you a list of times when we would use negative numbers and times when we would use positive numbers. So let's make a table with positive terms and negative terms. And I'm going to say the word profit. If you've ever heard of your profit margin, that's how much you're making. So profit is a positive term. If you owe money, you're in debt. And we would use negative numbers to express that. And you can think of the antonym here. So a gain is a positive term, but its antonym or opposite would be a loss. If you're above sea level, we're going to use a positive number to express that, like if you're 10 feet above sea level. And then if you're below sea level, like in New Orleans, we would say that's a negative number. And sea level would represent 0. And then you can make a deposit in the bank, which means that's money that you have. But then when you withdraw it, we can use that as a negative number, a withdrawal. You're taking it out. You're subtracting it. And those are just a few instances when we use, or terms that we use when we talk about positive and negative numbers. All right, why don't you try a couple on your own now? So our first example I need you to write down is write the number represented by a withdrawal of $400, and then for B, a profit of $56. And I would like for you guys to write down what numbers would represent those. So a withdrawal, look at your chart if you are confused. A withdrawal is going to be a, hopefully you said negative, so that would be negative 400. What about for the next one, a profit of $56? Yeah, we would use a positive 56. And you don't need to write the positive symbol, it's understood. And these guys right here are showing you, this guy probably owes some money. He can't find any in his pockets, and he probably owes some money. This guy is making some profits, some gains. He can make deposits into his bank. Next thing we're going to cover is ordering integers from least to greatest. Now whole numbers are pretty easy to compare, right? If it's a bigger number, it's a greater number. But when we deal with integers, negatives can sometimes be a little misleading because the bigger numbers, if they're negative, are actually the lesser numbers. And a way that we can keep from getting confused on this is to graph numbers on a number line and then write them in order from left to right. So number line's always your go-to if you ever get confused on integers. And I went ahead and made a number line here, and I went up to -5, or down to -5 rather, and across to 5. All right, now that you're making your number line, we'll go ahead and try an example using that number line. So our example is list -1, -3, 2, and 0 from least to greatest. All right. So we're going to graph each of these on the number line. So -1, I'm going to put a dot above -1. And then -3 is my next one. I'm going to put a dot above -3, which is over here. Then I have 2, that's over here. And then finally I have 0. I'll put it right above the 0 on my number line. So now I just read them from left to right. So -3, then -1, then 0, and then 2. If I wanted to do greatest to least, I would have done 2, 0, -1, -3. Just think, this is your positive direction, this is your negative direction. So least to greatest. So we'll write those down. Our answer is -3, -1, 0, and then 2. And this gets a little trickier too when we deal with decimals. That's why you always want to go back to this number line anytime you get confused. For instance, -3.5 would be here, and that is actually less than -3. So what did we find out? That the bigger the negative is, the lesser the value. So the bigger the negative, also the further left on the number line, right? -5 is further left than -4. So it is lesser. All right, so let's just try an example on that. If we were to compare -20 and -24, well, I don't feel like making a number line for that because those are some pretty big numbers, but I can definitely visualize from my number line, -24 is going to be way to the left, and -20 is going to be a little bit to the right of that. So the numbers that are further to the left are lesser, so I'm going to say that -20 is actually greater than -24. In other words, I would rather owe somebody $20 than $24, or $20,000 than $24,000. So that's why -20 is greater. It's more in the plus. It's more in the positive direction. Run. All right, and one more term I want to cover is absolute value. And to define absolute value, we need a ruler. And look at this ruler. Does this ruler have any negative numbers on it? Absolutely not. So the smallest something can be is nothing. And this is really a 0, isn't it? That's understood to be 0 right here. So even a molecule or an atom or a cell, something extremely small, still measures to be something. So that's going to be a positive number on how big it is or how much it weighs, right? Its mass. So absolute value is a distance. So it's the distance from 0 on a number line. So distances are always positive. Always positive. Or 0, right? They can't be any smaller than 0. So the smallest an absolute value could be is 0. Again, the smallest a distance can be is 0. Just think you're using a ruler to measure it. It's how far it is from 0 on a number line. So the absolute value of, let's say, -3 would be, well, let's count. How far is -3 from 0? It would be 1, 2, 3. Another example, how far is, let's say, 2 from 0? Or what's the absolute value of 2? Well, it's 1, 2 away from 0. All right, you try a couple now. Oh, and I almost forgot. We need to go over the symbol for absolute value. It's just two parallel lines, so I'm going to show that up here. If you could add that to your notes. Absolute value, just put that symbol next to it. Looks like the number 11, but you're containing whatever number it is, like -4, inside of that 11, or those two parallel lines. So example, -4. How far is -4 from 0 on the number line? And what do you think? If you said 4, you are correct. And that's because it's 1, 2, 3, 4 away from 0. So everything is in relation to 0. All right, try the next one. Example, absolute value of 3. In other words, how far is 3 from 0 on the number line? If you said 3, then you are correct. So it's 1, 2, 3 units away. All right, that absolutely wraps it up. So if you run away from negative numbers, I'm positive it'll catch up to you.